you so much for coming here today. You guys are about to be wowed. These 5 young innovators. They are developing solutions for challenges that we face today. Next, we're going to get ready for Ray. Ray is an undergraduate student from UBC who is creating an innovative solution for cost-effective and sustainable 3D printing. Let's welcome Ray to the stage.
So what do you think consumes more plastic? A single 3D printer or Starbucks with their plastic straws? Let's crunch the numbers. Turns out, one single 3D printer consumes the equivalent of 5,142 plastic straws in a single day. And that's equivalent to 10 1/4 Starbucks stores worth of plastic. And when you got 5 of these machines prototyping, it adds up to a lot of plastic. The second problem is that 3D printing isn't very strong, as you can see. So, what is the solution? The solution is Solvent-Polymer Deposition 3D printing. This is a 3D printing process that uses a carbon fiber composite that's been dissolved into a liquid using a solvent. This is then extruded out directly through a special extruder like this into a directly 3D print part like this, or it can be combined in a hybrid process with traditional 3D printing to fill the inside of a traditionally 3D printed shell. This material is fully recyclable and can be reprinted over and over and over again. Not only that, the chemical bonding in between each individual layer and the internal structure that resembles bone, one of the strongest materials found in nature, makes this material 7 times stronger than conventionally 3D printed ABS plastic. 3D printing is the future. So let's make it sustainable and let's make it practical. This is my reality revolution solution. Thank you.
That's great. Great job, Ray. Talk to us about the cost.
This is actually one of the cheapest ways to manufacture carbon fiber parts. The cost associated with producing carbon fiber parts is actually the process of wrapping layers and layers of carbon fiber around your mold. This is a way of 3D printing carbon fiber directly, and when it comes out of the extruder, something actually really cool happens that I didn't know about before. The individual strands of carbon fiber actually align naturally to form into a single direction, and it gives the parts like the strength close to what you get with real carbon fiber manufacturing. And also, the cost of this is actually, the cost of this material compared to traditional 3D printing is actually $5 a kilogram for this material, as opposed to $25 for just your normal plastics.
Oh, wow.
And it comes down to the whole extrusion process. And that's basically when you have a 3D printer, it takes something called filament. And filament has to be controlled at a very precise diameter. That means this plastic has to be extruded through a hole, pulled at very constant speed, measured through multiple laser beams to actually measure that diameter. This process, because it's a liquid, you don't really care. As long as you get the mixing ratios right, you dump your whole batch of like ABS pellets in there, mix it with your solvent, mix it with your carbon fiber, and you're set to go.
Great, great. Have you done any patents?
So in terms of patents, I actually don't believe that it's right for me to patent this.
Okay.
And that comes down to the fact that I wouldn't be here today if somebody in the 3D printing community had put a patent before. 3D printing is built upon being open source, and that's one of the reasons why I've not decided to patent this, and in fact shared it with everyone else. And if anyone in this room wants to pick up on this and make it better, go ahead. Because why would I prevent a technology? Why would I prevent somebody else from taking technology that will make the planet a better place?
Incredible. So I'm interested in what the next steps might be for you in terms of trying to bring this to market.
So right now, I actually run my own 3D printing business, and I'm testing this, even though some of them might not know about it. I'm actually testing this on my current customers. Sometimes I have clients come to me and they're like, I need a part for engineering, and I want it to be strong, and I want it light, and also, can you make it cheap? Like to a point where I'm not even actually paying myself. And that's a typical thing with clients. They want it for free, pretty much. So I'm just like, okay, maybe this is a good chance for me to test it on a new client. So I'm using the second hybrid process where I print the outer shell using conventional process to give it that resolution. As you can see, the layer lines on this directly printed piece are a bit thick, but with the hybrid process, you can get the same strength without the material and with the strength of this part. That's currently testing it on clients that might not really know about it yet.
That's great. Thank you very much.
Thank you.
I think
Great,
you might
great.
have to go to Manjit's price negotiation
Exactly.
class. Or no.
But,
Great.
but congratulations.
Thank you
great,
very much.
great
Yeah, that's
product.
great.
Thanks.